Okay, ladies and gentlemen, one last one for applications. Example 3. Ashley sells her gourmet sub sandwiches for $8 a piece. At this price, she usually sells 100 of them. And she sells 100 a day. Ashley is considering raising her price. After an informal survey, she concludes that for every 50-cent increase, she's going to sell 5 fewer subs. I promise to put a question like this on the test. You'll have different numbers, but you're going to have to figure it out. So let's go through this. First of all, you need to know what revenue is, and you need to know what profit is. Revenue means all the money that comes in. Profit is all the money that comes in after expenses. So now, she just wants revenue. So revenue is going to equal all the money collected. That's a good way to think about it. Now, in this case, what's going to determine all the money collected? It's going to depend on how many subs she sells, times the price per sub. So it's going to be the number of items sold times the price per item. Does that make sense to everyone?
Yes.
Okay. Now we've got to be careful here. We have a dynamic situation. She wants to raise her price. She wants to raise it in increments of 50 cents. Every 50 cents she increases her cost, she's going to lose 5 customers. This might be a good thing, this might be a bad thing. Her price might go up and she might make more money. But she might lose so many people that she starts losing money. This is the dynamics of the problem. This is what we have to figure out. So, the number of items sold and the price per item all depend on one thing. What? Anybody? I'm asking you guys. It's all going to depend on the number of 50-cent increases. That's what is important. That is going to change everything. So that's what we're going to let X be. Let X represent the number of 50-cent increases to the original price of $8. Now think about that for a minute. How does each one of those increase affect this situation? Well, the revenue is based on the number of items sold. And it's 100 minus 5x. Because every time she raises her price by 50 cents, she loses 5 customers. Does that make sense? I think so. And the price goes from $8 plus 0.5 for every increase. So look at how X is affecting it. X is the number of increases. For each increase, I lose 5 people. For each increase, my price goes up. Think about this equation. Notice that a 5x times a 0.5x is going to give me a x squared. This is a quadratic. We can solve it. So what we need to do is put it into standard form to start before we do anything. So in standard form, it's going to be 100 times 8, which is 800. 100 times 0.5, which is 50x. 5 times 8, which is negative 40x. And then 5 times 0.5, which is negative 2.5x squared. Let's put that in an order that we are more familiar with. And we have a lovely expression for the revenue in terms of the variable x, which instead of writing revenue, I'm going to show as r of x. So the question is asking for what price should I charge to maximize revenue? How do I find a maximum with a quadratic? What do I look for? Pardon me? No, common factoring is not going to help me. Not in this case. Negative doesn't mean much. The square thing, because completing the square thing is going to let us find what? What does completing the square give us? The vertex. And isn't the vertex that... everybody in the studio audience is now having an epiphany. So we're going to need the vertex. Notice that this is a parabola that opens down, so we're looking for something that looks like this, I hope. And we're looking for that maximum where revenue is along here, and this is the number of 50-cent increases. I just use a little arrow sign to show increases to the price. So, we need to do that complete the square thingy, as it was so nicely said in class. So we're going to complete the square. So it's going to be negative 2.5x squared plus 10x, all in brackets, plus 800. You got to common factor out that negative 2.5. So 10 divided by 2.5 is negative 4. So negative 2.5 bracket x squared minus 4x plus 800. Now I go for the magic number. The magic number is going to be half of 4. So it's 4 divided by 2 is 2. And if we multiply that by itself, we get 4 again. So this is going to give us negative 2.5 x squared minus 4x plus 4 minus 4 plus 800. That negative 4 we don't really want. It's not part of my perfect square trinomial. So the negative 4 gets multiplied by negative 2.5, which is 10. So it's going to be x squared minus 4x plus 4 plus 800 plus 10. Now, someone in the audience asked me earlier, what happens to this trinomial? This is a perfect square trinomial. So we look for two numbers that multiply to give 4 and add to give negative 4. It's going to be negative 2 and negative 2. So that actually becomes, I don't want to confuse anyone with this, but this is what it happens to it. Just trying to answer a question while I'm doing this. So it actually becomes that, which we write as and the shortcut for being able to do that so that we can skip this line, especially when we have decimals, is noticing that this number here is the magic number, which someone else in the studio audience correctly noticed that that magic number shows up here again. So the magic number is here, shows up here, and shows up there in your vertex. So our vertex is going to be 2, 8, 10, which means that we're going to hit a maximum revenue of $810 when she has 2 increases of 50 cents. to the price of $8. So the price to have her maximum revenue is going to be $9, and her maximum revenue is $810. So a price of $9 gives max revenue of $810. That's it for me. We'll talk to you soon.